We're going to look at creating dilations in a coordinate plane. Now, to remind you, a dilation is the same shape, but it has a different size. Okay? So that's an important thing to remember. It's also important to remember that on a dilation that you have a center. So that center, all of the points of the shape are expanded or contracted or reduced from that. Okay? And remember that our scale factor is what tells us what the ratio is between the two sides. And you can always find the scale factor by using the image over the pre-image. Okay? So if we look here, when we're dilating, if the center is at the origin, okay, all you're going to do is you're going to take whatever the point is and you're going to multiply both the x and the y value by the scale factor. Okay? However, that only works if it's the center, okay, at 0, 0, or the origin. Okay? So let's try this problem and then I'll show you how we can do it when the center isn't at the origin. Okay? So if we draw a picture, we have A is at -4, 4. B is at 6, 6. C is at 6, -2. And D is -4, -4. So here is my quadrilateral. Oops. Okay. And we know that our center is at 0, 0. So all of our points are going to be expanded or condensed from that value, or from that center. So now what we can do is I can take each of the points and multiply the x and the y value by the scale factor. Okay? So in this particular one, it says determine the new vertices if it's dilated by a scale factor of 1/2 and centered at 0, 0. So if A is -4, -4, A prime is going to be -4 times by 1/2 and 4 times by 1/2. So then that just is going to be our A prime is -2, 2. So if we do, let's go different color, -2, 2. So there's our A prime. And then if we look at B, I'm going to do 6 times 1/2 and then 6 times 1/2. So that gives us that B prime is 3, 3. So B prime is 3, 3. And then C prime, we're going to take 6 times by 1/2 and -2 times by 1/2. So that gives us 3, -1. 3, -1. So there's our C prime. And then D prime is, we're going to take -4 and times it by 1/2 and -4 and times it by 1/2. So that gives us -2, -2. Now, remember that a dilation is that the angles are still the same. The corresponding angles are still congruent. So these angles match, these angles match, these angles match, and these angles match. Okay. You have another piece of information that if you take the center and you create your projections lines, so you go from the center to the image and pre-image points and connect those will all be collinear. Okay? So that's something that happens. So that's another way you can quickly check and see if something is not a dilation. So if we go back and we look at this one, if we have this picture here and this one here, notice our center here is at 0, 0, right? So if we look at creating our line between the image and the pre-image points, notice this one, it's not collinear, right? It creates two segments. So we know that this one is not a dilation because of that. Okay. So that is something that we also know with a dilation. Okay. We also know that the corresponding sides are parallel. So these two would be parallel, these two would be parallel, and these two would be parallel, and these two would be parallel. Now it looks like a parallelogram, but I haven't checked, so we're not gonna, you can't check. You would need to just double check your slope here and your slope, excuse me, here. Make sure that it's the same. But all the corresponding sides are parallel when you have a dilation, so you have that aspect as well. Now remember that when you have a dilation that the sides are proportional. So if we compare this side to this side, we've got 1, 2, 3, 4, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. So this is 4 and this is 8. And then this is 4 and this is 8. And then we would need to use our Pythagorean theorem to find, or a distance formula to find this one. So we've got 1, 2, 3, 4, 5, and then 1. So we would do 5 squared plus 1 squared square rooted would be this distance here. So that would be 25 plus 1, which is the square root of 26. If we look at this one, we've got, this is up 2 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'd have 10 squared plus 2 squared square rooted. So that's 100 plus 4, which gives us 104. And we would need to check that those are proportional, or we know that these are proportional because we know that this is a dilation. To show you where it's more obvious, if we break this down, this is 2 and 26. This is 2 and 13. So then when I simplify this is 2 root 26, which notice to go from root 26 to 2 root 26 was a multiple of 2, right? Since the red is the big one, we should really be going from, this is 1, oh, this is 2 root 26, so you take the image size first, so the 2 root 26 over the root 26. The root 26 cancel. Oh no, I went backwards. The image is not the 2 root 26. This is the pre-image. So I went root 26 over 2 root 26. Those cancel, so then that gives us 1/2, right? Which is our scale factor that we have over here, right? So you can also be aware of those things as well. Now, notice here that our slope, that it doubled by the scale factor. So if we double 5, it gave us 10. If we doubled 1, it gave us 2, right? So that same kind of thing is applicable in just a minute. Now, I also want to remind you that if we were to look at this projection line and compare it to this projection line, that it would be that same scale factor as the dilation. So there's a whole bunch of different parts where the dilation scale factor comes into play. Now, when we're not centered at the origin, it takes a little bit more work, but it's not more complicated. So what we're going to do, this is an explanation for what I'm going to tell you. So what we're going to do, I'm going to, draw this triangle. So A is at -1, 1. B is at -4, 4. And then C is at -5, 3. Oops, C. Okay. -1, 1, -4, 4, -5, 3. Yeah. Okay. So our center in this case is at -5, -1 with a scale factor of 2. So -5, -1, so this is our center. Okay. So instead of looking at the x and y values and multiplying them by the scale factor, we're going to look at the slope from the center to each point. Okay. So I like to do the slope from, the center to A. So if I'm going from the center to A, I'm going up 1, 2 over 1, 2, 3, 4. So up 2 over 4. Okay, so then what we're going to do is we're going to take the scale factor, which in this case is the 2, and I'm going to multiply it by both the rise and the run. Similar to here, how when we were looking at, we were using our distance formula or Pythagorean theorem to find the lengths of the sides. Notice that the rise and the run both got multiplied by whatever the scale factor was. So this would be up 4 and over 8. So then what I'm going to do is I'm going to go from my center point, and I'm going to go up 4, 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. Was that the right point? 1, 2, 3, 4. Yes. So this is A prime. Okay. Then I'm going to do the same kind of thing with B and C. So to B, we're going to go, okay, this one up 1, 2, 3, 4, 5, and over 1. So I'm going to multiply the scale factor, which is 2. So I'm going to go up 10 and right 2. So if I go up 10 and right 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right 2. So my B prime is there. And then I'm going to do the same kind of idea with C. So my slope from the center to C is up 1, 2, 3, 4 over nothing. So we go up 4 over nothing. I'm still going to take this scale factor and multiply it by both the rise and the run. So this will be up 8 over nothing. So then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So then there's our C prime. And I can do some quick checks to make sure that I haven't royally messed up anything, right? So those look parallel. These look parallel. These look parallel. I can check and see that what an actual line, from the center and then the corresponding side, corresponding vertices make collinear lines, or are collinear. So then notice that would be where we're expanding and condensing it from, right? If you wanted to, you could find your lengths of these and check that it has the scale factor of 2. That's lengthy because you have to use your rise and run or your Pythagorean theorem or the distance formula to find those, right? So those are some quick checks to make sure that I've not done anything horribly awry. Okay? So let's have you try this one. So pause the video and try this one. Okay, let's check and see how you did. So our center is at -2, -5, which happens to be the same point as L, right? So here, if we're going from the center to L, that means we went up nothing over nothing, which means we're going to times that. Since our scale factor is 3, we're going to times that by 3, so that means we would go up nothing over nothing. So L, L prime, and the center are all on the same point. Okay? Then M, to get to M from the center, we're going up 2 and over 1. So we're going to times that by the scale factor, both the rise and the run, by 3. So we're going to go up 6, right 3. So then up 1, 2, 3, 4, 5, 6, 1, 2, 3. So there's our M prime. And then we have our N. To go to the center to N, we're going to go up 1 over 1, 2, 3, 4. So I'm going to times that by 3, both the rise and the run. So that gives us up 3 and over 12. So then I'm going to go up 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there is our N prime. So then notice we can do a quick check. Those look parallel. These are parallel, and these are parallel. And then if I create from the center to my corresponding vertices, it's collinear, or in this one case, it's the same point. So they're all on the same point, so it's fine. So that is what you should get for your answer. Now try this one. So pause the video and try this one. Okay, so if we check here, our center is located at 1, 2. So from the center to the different points, so to A. Now, I do want to let you know that this way for not at the origin will also work for the one at the origin. So if you want to remember just one that works every time, remember this one. So from the center to A, we're going down 1, 2, 3. So I'm going to go down 3 over nothing. So then I'm going to times, our scale factor is 1/2. So I'm going to times both the rise and the run by 1/2. So 3 halves, which is the same thing as 1 1/2. And then over nothing. So down 1 1/2 over nothing. So there's our A prime. And then to B, we're going from the center over 1, 2, 3, 4, down 1, 2, 3, down 4, right 3. That was to B. So we're going to take that and we're going to times that by 1/2 on both the rise and the run. So that gives us down 2, right 1 1/2, or 3 halves, whichever way you want to think of it. So from the center, we're going to go down 2, down 1, 2, and over 1 1/2. So that puts us here. So our B prime is there. And then we have C. To get to C, we're going up 1, 2, 3 over 1, 2, 3. So we're going to times that by 1/2. So that gives us up 3 halves, right 3 halves. So 1 1/2. So up 1 1/2 over 1 1/2. So it puts us like in the center of that grid point. So there's C prime. And then we've got D. We're going from the center left 2 over nothing, or sorry, left 2 up nothing. No, let's try again. Up nothing, left 2. There we go. So we're going to times that by 1/2. So that would be up nothing, left 1. So there's our D prime. So then if we create our picture, oh, something looks wrong with B. Let's go back to B. Down 1, 2, 3, over 1, 2, 3, 4. Oh, I reversed them. Okay, so then B, so I knew that something was wrong because those did not look parallel. So I went 1, 2, 3, 4 over 4. Over 4 and up 3. So we're going to go right by 1 1/2. No, up by 1 1/2. Down by 1 1/2. Goodness gracious. Down by 1 1/2. Right by 2. There we go. Now let's see if it looks fine. Yes, so now these look parallel and now these look parallel. And then if we create our projection lines, notice that they are all collinear. Oh, I missed. So I have that going for me that works nicely. So that's how we do our dilations, both when the center is at 0, 0 and when the center is not at 0, 0.